Hello friends, welcome to Smart Engineering Academy. This is an online video tutorial on STAAD.Pro software. In this video tutorial, I am going to teach you analysis and design of a simple framed structure building by gravity loading using STAAD.Pro software. So let us know about STAAD.Pro software. The STAAD.Pro is a structural analysis design program software choice for concrete and steel design. It is used for 3D model generation, analysis and multi-material design. It is one of the software applications created to help structural engineers to automate their tasks and to remove the tedious and long procedures of the manual methods. And also sharing capabilities with other major software like AutoCAD and MS Excel. It includes a state-of-the-art user interface, visualization tools and international design codes. The commercial version of STAAD.Pro supports several steel, concrete and timber design codes. Let's see about history of STAAD.Pro. STAAD.Pro was originally developed by Research Engineers International in Yorba Linda. In late 2005, Research Engineers International was bought by Bentley System. Latest release STAAD.Pro version 2008. Structure. In STAAD.Pro software, the group of elements we are calling it as a structure. The STAAD is capable of analyzing and designing structures. In case of STAAD.Pro, node becomes joint equals it has a number exist on initial, final and junction point with XYZ coordinates. In shortcut key, we are using Shift plus N, that is for node number. Beam becomes member equals it has a number and connect nodes on its start to ends. The shortcut key Shift plus B, that is for beam number. Plate becomes element equals it has a member exist on XZ direction. Surface becomes sides, it equals it has a shear wall exist on perpendicular direction of an object. Types of structure. So in the STAAD.Pro, we are having space structure, plane structure, floor structure and truss structure. A space structure, which is a three-dimensional 3D framed structure with loads applied in any plane. Usually y-axis is taken to indicate the vertical direction and XZ represents the horizontal plane. A plane structure is a two-dimensional 2D framed structure bound by global XY coordinate system with loads applied in the same plane. Similarly, a floor structure is a 2D or 3D framed structure in the horizontal XZ plane. The next one. A truss is a 2D or 3D structure consists of truss members which can have only axial forces and no bending in the members. These are the terms used in the structure in STAAD.Pro software. The first one it is beam, column, slab or plate or element, shear wall, support, section properties, loads assigned, run analysis, post processing and RCC design. Model generation. For the model generation, there are basically three methods of generating a model. First one it is add beam or snap node method. Second one STAAD editor or coordinate method. Third one structure wizard or copy paste method. Let us know about the snap beam method. So snap beam method are the graphical based approach and is frequently used in STAAD.Pro. Next one, STAAD editor. STAAD editor are the coordinate based programming language method, complex, but editing is used if any kind error is occur. STAAD.Pro also contains a command structure wizard, which is its library of structures such as frames, trusses, slabs, beams are present which can be merged with the STAAD.Pro model. By using these three methods, a structure of any geometry can be created. Out of these three methods, most commonly used is copy paste method. In STAAD.Pro software, we can also analyze and design the shear wall and foundation substructure, and also steel transmission tower, steel truss, water tank, staircase and cable bridge. Let us open the STAAD.Pro software. So here you can see the STAAD.Pro, the initial window. Here we have to click the Advanced Analyze Engine and Indian Design Codes before selecting the new project. Okay, let us open new project. Okay, here we have to select space structure for 3D model, create file name, model 1, and select the location of the file. Okay, and also you have to set the units. It should be in meter and kilo Newton. Click on next. So next, add beam, finish. You can see the STAAD window here. So this is menu bar, and this is toolbar, and this is main window. Initially we are doing the snap node or add beam method. Along y direction, the nodes has been created. Next, select add beam option. Select all the nodes. Go to geometry. Go to go to break beams at selected nodes. So now the 3 beams has been created. After creating the nodes and beams, by copy paste method, select all the elements, Control CV. By X direction, give 3 meter spacing, again 6 meter, repeat at 9 meter. Okay, and select all the elements and give Control CV. Copy paste in Z direction, repeat again 6 meter, copy paste again 9 meter. You can see it is in isometric view. You can also see in other views, that is in Z direction, X direction and Y direction. Okay, so now you have to create the plinth beams. For that you have to select the plinth nodes and go to view. So here you have to select the view selected objects only and give isometric view and starts create beams. After creating the beams, select the nodes, go to geometry, break beams at selected nodes. Now the 16 new beams created. So go to whole structure view. You can see here the plinth beams are created. You can rotate the whole structure by using rotate option. Now go to Z direction view, select the plinth members, go to geometry, go to translation repeat. So here we want these plinth members in the next floors, so that is in Y direction. The spacing between the floors, it is 3 meter. Now you can see the whole structure view. Now the model is created by using copy paste method. The next step, go to general. So in that we have to assign the properties for the vertical and horizontal elements. Go to sectional properties. So here we have to define the sectional properties for columns and beams. So select rectangular sections. So give the sizes of the columns, and same for beams. And select the column property. Select beam parallel to Y direction. Assign to selected beams. Assign. So now it is assigned. So repeat the step for beams. Select the beam property. Select beam parallel to X direction as well as Z direction. Assign to selected beams. Click on assign. It has been assigned. Now after assigning the sectional properties of beams and columns, now we have to give the supports for the columns. So in the Z directional view, so go to support, create the supports for the foundation, fixed, add, select support 2, select the foundation nodes, assign to selected nodes, assign. It has been assigned. Now you can see the whole structure in the isometric view. Okay. Now we have completed the model. Here you can see the some of the following tools in this window. So structure. So here you can see the 3D section in full sections, sections outline. So click on full sections and apply. OK. You can see here. So the isometric view in full sections. So click on sections outline, give apply. OK. Also you can see the isometric view in sectional outlines. So and also we have to label the nodes, node points, supports, dimensions, and also the member numbers, design group, design envelope, design brief, and also properties, references, sections. So beam numbers, beam orientation, okay, plate numbers, plate orientation, solid numbers, etc. Okay, also you can see the rendering view for this structure. You can see the rendering view of the 3D model structure. Okay, so the next steps involves in the loads and load combinations and analyzing the structure by gravity loading, explained in the part 2 of the video tutorial. Thank you friends. Next you again in the part 2 of the video tutorial.